All right, Algebra 2, Lesson 7-6, Interpreting Exponential Models, the advanced version. So this builds off of yesterday and the day before that, so Monday and Tuesday. Today's date, of course, is Wednesday, April 10th, 2019. Say hi, Chris.
Hi. Hi, Chris.
All right, we miss you, Chris. All right, so example 1. We are assuming that we're talking about bacteria. B for bacteria, so capital B for bacteria. My initial amount is probably 1,200. My common ratio is 0.92, and something is happening. I need to do t divided by 5. The trouble here is I want to know how many or how much this is decreasing by every second. Every second, every 1 second. The problem with this is when I plug in 1 here, that is every 1/5 of a second. Yeah, what's up, Fiona? I'm just kidding. Okay. So I want to convert this 0.92 into, and let's go ahead and write this in our notes too, this 0.92 needs to be turned into something, I don't know what it's going to be, something to the power of t. I need to figure out what that something is, and that is going to be my answer. I just want every second. So how do I make this something with not divided by 5? Well, if I go ahead and multiply it by 5, for example, I do to the power of, sorry, this is really two things, right? This t over 5 is really 1/5 times t. There are two things that are happening there. There's a 1/5 and there is a t. We know from rules of exponents that we can separate those two. I can have one and then the other. So I'm going to do, on the inside, I'm going to do 0.92 to the 1/5, and I'm running out of room, let me save some space, 0.92 to the 1/5 to the power of t. All right, I basically just solved this for us, but I need someone to re-explain, regurgitate why 0.92 to the 1/5 is basically, I mean we have to do one additional step, but that's basically our answer. Why are we allowed to take this 0.92 to the t over 5 and change it to this? By raised hand, who can regurgitate what I just said? Go for it, Andre. Yeah, so explain more. Yeah, exactly. I mean, yeah, so I factored. That's the main idea. T over 5 factors to 1/5 of t. I know from rules of exponents, a power to a power, this is a power, we can all nod our heads, that's a power of 1/5. A power to the power of t means you're multiplying these numbers. That's why I'm allowed to rewrite this 0.92 to the t over 5 as 0.92 to the 1/5, and then to the power of t. But look, that's what I was trying to get. I'm trying to get something to the power of t. Here is that something. Question? No. Can you again? All right. So what I want to do now is I want to open up, first of all, thank you, Andrea. You can turn in your card. I want to open up my calculator. If I go to a new tab and go to desmos.com/scientific, if I go to my calculator and I type in what is 0.92 to the power of 1/5, 0.92 to the power of 1 divided by 5. That is 0.9834. And I can zoom in here so you can really see what's going on. 0.9834. So now we need to answer the question. And I can write this down in the notes too. I need to grab the correct pen. So I'll do this in a different color. So 0.9834, 0.9834, all of that to the power of t. That's rewriting that 0.92 to the power of 1/5. Question, Fiona, for realsies this time?
Well, I don't have a question.
You just like raising your hand, or you're trying to participate?
Well, I was just going to say the thing.
Oh, the answer. Yeah.
Is it 2%?
It is 2%. Yeah. Can you explain more why? That is the correct answer.
Because it's do something with a 1.
You do something with a 1. What do you do exactly with a 1?
Well, I just know that if you add 2 to 98, you get 100, and that's like 1, like...
Yes, I mean, I can explain a little bit more in depth, but you do have the answer, so let me come back here
Okay,
and give you the XP for it. So Fiona, you can turn in your card. You can maybe try to throw it into here or do a cutoff or destroy your card.
That ain't it.
So the idea that Fiona's trying to convey to all of us is you start with 1. No matter what, if you're going up or down, you always start at 1. You always start at 1. And then you either add or you subtract something. And that something is what I'm looking for. In this case, I subtracted 0.02 or 2%. If I do 1 minus 0.02, I get 0.98. And of course, rounding, those guys go away. So I get 0.98 if I do 1 minus 0.02. So then there's like a little drop down for Khan Academy. Is that added to or subtracted from the total number of bacteria, Fiona? I'm trying to circle either addition to or subtraction from. I don't know which one to choose. Why? Exactly, yeah. Subtracted from. I circled the subtract sign, so it's a dead giveaway. Yes, another way of thinking about it is 0.98 is less than 1. If it's less than 1, I mean, that's technically not correct. It needs to be between 0 and 1. But generally speaking, if it's less than 1, it's decay. Decay means subtracted. If it was greater than 1, it would be exponential growth. Growth is added to. When I grow, my height is added to itself. All right, so I don't know why I undid that. Let's go to another example. Example 2. This is what I consider to be one of the trickiest problems. I'm talking about some random radioactive element. I could have done a little bit more research and found an actual radioactive element that did have this decay rate. I totally made up this number though, 0.98. So this common ratio, 0.98 to the power of 6t plus 3, and t is measuring weeks. I need to figure out what's happening, or what the factor is. So I need to figure out what this base number is every 1 week. It says every week, not every 6t plus 3 weeks, every week. How am I going to do that? And I'm going to let you think about it for 10 seconds, and then I'll be looking for hands. How am I going to just do that for something to the power of t? Again, it's the same question as last time. I need something to the power of just t. How do I get just something? That was roughly 10 seconds. How many people have an idea how to start this one? All right, Fiona, go for it.
Can you factor out the 3 of the exponent?
You could factor out a 3, so you're thinking of doing something like, let me go off here for some scratch work. 0.98 to the power of 3 times the quantity of 2t plus, my t's and pluses are looking, I'll curve that one, 2t plus 1 like that?
Sure.
Or were you thinking of something else?
I kind of forgot that you had to do the plus 1. So.
Oh yeah, it's a good idea. You're trying to somehow get rid of that plus 3 because it's a pesky plus 3. If we got rid of it, then it turns into this problem where it's just multiplied or divided by something, right? Unfortunately, this doesn't work, factoring that out. It's a good idea, but not quite. Not quite there. Still get XP. Anyone else want to give it a shot? I honestly forgot about it unless I had to think about it for like 2 minutes and like, oh yeah, that's right. So let me go back to this property. If I have some base, I'm going to call that base B. I could call it X. I could call it A. I'm going to do some base B. Write this down in your notes. If I have some base B and I have it to the power of, I'm going to randomly choose letters Z plus X. That can be rewritten as something else. This thing is equal to B to the power of B to the power of with a multiplication sign. Do we remember this rule? Who can help me remember this rule? B to the power of Z plus X is equal to B to the something, B to the something. How many people remember this? I see Fiona, Gio, Andrea, Teflon. Go for it, Gio.
Is it B to the power C times B to the power X?
It is indeed. I can rewrite it as 2 different things being multiplied by each other, as long as they are the same base. Yeah, thank you, Gio. This is kind of going backwards with one of our rules. That means my first step here is going to be to rewrite this. I'm going to rewrite this as, and if you have room somewhere in your notes, you can do it below, because we're not going to write anything below, or you can do it up here. I'm going to rewrite this as 0.98 to the power of 3 times 0.98, that same base, I'm just kind of copying from this formula, to the power of 6t. All right, I don't know how many people I lost. Can I get a fist of 5? How well are you following example 2 so far? All right, Teflon, what's going on?
I don't get this.
You don't get this?
Nope.
All right, I will explain one more time. So the idea here is we can't do anything with this 3. There's no way to get rid of it. So our method of getting rid of it, Teflon, are you looking at the screen? Okay. Our way of getting rid of this 3 right here is to use this rule where b to the power of z plus x, I can separate this by multiplying 2 of the same bases. It's the same base here, same base here, same base here. Just like we have same base here, same base here, same base here. The trick is when they're added, I can just multiply with the powers being the original powers up here. So that's what I'm doing. So far so good? Would you increase your 2 to something higher? A 3 or a 4? Okay. From here, I don't care about this term at all. It doesn't have a t in it. I'm only caring about the terms that have a t. So don't worry about this first term. That's kind of like the initial value. What I'm going to do is I'm going to come over here and I'm going to somehow rewrite this term, only this term, as something to the power of t. What is that something? And this is a review from example 1, slightly different. How do I rewrite this as something to the power of t? What goes in there? Gio has an idea. Fiona has an idea. Stego has an idea. Stego takes it back. We're down to 2. All right, Gio, help us.
I'll take it.
Oh no, we're only down to Fiona. Stego, go for it.
So 0.98 to the 6, and then to the t.
0.98 to the power of 6, all of that to the power of t like that? You are indeed correct. Everyone write it down. Stego has the answer. Thank you, Stego. You can turn in your card. 0.98 to the power of 6. And then that is something to the power of t. So now I just have to figure out what is this 0.98 to the power of 6, and that's where I just pull up my handy-dandy calculator. 0.98 to the power of 6 is 0.885, and I'm just going to round to the nearest whole number. So 0.88, let's say 0.886 for now. So this number right here is 0.886. Yes.
Why'd you cross off the one with the 3?
So we don't care about it because it doesn't have a value of t. We only care about things that have a t in them. So I'll write that out as well. This doesn't have a t. No t, don't care. All right. So now I need to finally answer the question. Every week the mass is multiplied by a factor of, and that's the answer, 0.886. I guess we can round it to 0.89. I think Khan Academy usually likes 2 decimal places, so let's actually do 0.89. You should never round once and then again, but it's fine for this case. 0.89 is our answer. Whenever it's asking for a factor, this keyword factor, can we underline factor 2? That's the easiest case. It's just asking what is the base. Whenever you see the word factor, it's asking what is the base. You don't have to do any extra things like adding or subtracting from 1. It's just saying, hey, what was that number in the equation? All right, our third and final example, another tricky guy. I started to lose creativity in the morning, so I'm doing another radioactive element. So now I need to do a sample that is decaying every how many months? But it has to be now a factor of 3/4. So this is a slight twist, a slight deviation on our last problem. Again, we don't care about the 150 because it doesn't have a t in the exponent. So cross it off. We don't care about him. We only care about this 27 over 64ths to the power of t. Somehow this needs to be transformed into something. I don't want to give away too much. Can someone tell me what we're trying to get this to using 3/4 in your answer? Fiona has an idea. Anyone else? What are we even trying to get to? What form is it trying to force us to? In the previous form, it was trying to say something to the power of t. That's no longer the case. What form is it trying to force us to? And again, you have to use this 3/4 in your answer because it says that needs to be the factor of 3/4. All right, Fiona, give it to us. Oh, no. It's saying that we need to have a factor, so it needs to have a base of 3/4, and we don't know what this guy is up here. What is this guy? Try to find this guy. So I'm going to do like an empty box or a question mark. We don't know what goes to the very top power. Andrea? Okay. Fiona? Oh, you're already thinking 3. Yeah. You are correct-ish. Tell us why.
Because 3 to the third power is 47 and 4 to the third power is 64.
Yep. So I can rewrite 27 over 64 as, let's go ahead and say this guy right here, 27 over 64 is the same thing as 3 to the power of 3 over 4 to the power of 3, which is the same thing as 3/4 that entire fraction to the power of 3. So what goes in this box? It's not just 3. So Fiona gave us the fact that it's going to be 3/4 to the power of 3, but I need someone aside from Fiona, because she's been carrying a lot of weight today. Someone aside from Fiona, tell me what goes in this box. 3 is going to be part of it. I'll give you that much. You missed? No. If you made it, he's fine. Stago, you think you got it? 3t, yeah. So that is our answer, you guys. 3t. Our answer is, well, the thing that goes in the box is 3t, but we still haven't answered the question. The question is saying, how many months?
3.
You have to be careful here, because remember when we had, back from yesterday and Monday, when we had t divided by 5.1, our answer was 5.1. It's whatever is being divided by, right? But now we're multiplying by 3, so we have to do the inverse of multiplication. Every opposite of multiply by 3, I think Fiona has the answer, but I want to try to give it to someone else. This means every 5.1 weeks. This is not every 3 weeks. It's every something weeks, though. It's a fraction. Teflon, you got it? Take a guess. It has 3 in it somewhere. It is 1 over 3. Final answer, every 1/3 months. If it's being divided by 5.1, it's just 5.1. The answer right here would have been just 5.1. But if it's being multiplied, then you have to do the reciprocal of that, 1/3 months. All right, that was one homework assignment. 1, 2, and 3 are one homework assignment. Example 4 and 5 are a different homework assignment. I consider these to be a little bit easier. I'd call example 4 and 5 a difficulty of 3 out of 5. These ones were a difficulty of 4 or maybe 4.5 out of 5. All right, so here we go. I'm just going to go ahead and explain this to go nice and fast. So I have a function y that represents the number of people in a crowd who yawn every t minutes. So if it was my class, it would be like 1,000 or something crazy. Everyone's yawning here, right? No? No? Okay. So every t minutes, but I want to figure out how many people are yawning every hour. So I have to do a unit conversion. First of all, quiet raise hand. I want to get some more people that participate. And I'm only calling on people that have their cards still. How many hours or how many minutes are there in an hour?
60.
Quiet raise hand, please. Thank you, Eva.
60.
That means there are 60 minutes for 1 hour. We need to have that information to begin with. Yes, now we're getting some more people in. Good. That means we need to rewrite, again, we don't care about this 3, cross it off. For this, all of this homework assignments, I don't care what the initial value is. I only care about the common ratio. I need to now rewrite this 1.02, but changing the units. 1.02, and I have to do something to this power. So this, I'm looking for something that goes right here, some modifier, and then that's still going to be to the power of t. What is that modifier? I see Gio and Fiona's hand. Still have not heard from Teflon or James yet today.
Yeah, you did.
I did? Okay, James, just on you. Oh, that's right, you did. I'm not going to put the pressure on you, James. I'll give you an advance warning. Yeah, Gio, tell me.
Is it 60?
Yes, it is 60. Hey, you just multiply by 60. I need more things. I had minutes, but I need it to be longer. I need more of them, so I need to multiply by 60. And it's always a tricky thing to determine if you need to multiply or divide. The general idea is if you need more, multiply. If you need less, divide. I need more things to get to hours, so I need to multiply by 60. So our answer is going to be, since it's always asking for factors, you just need to do 1.02 to the power of 60. 1.02 to the power of 60. 3.28. I'm going to round to 2 decimal places, just kind of randomly. So the answer here is 3.28. And again, that's just 1.02 to the power of 60. Kind of straightforward. The tricky part is knowing if you need to multiply or divide. All right, let's go to example 5, and then we're done with the notes. Oh, sorry, I'll leave this up here still. All right, I'm talking about a tree. Maybe that tree right there. I don't know. So B is going to represent branches. B for branches. Every t years, I have this exponential function that tells me how many branches are going to be on the tree approximately. Obviously, I can't have a half of a branch. I don't even know what that would look like. Maybe the branch is snapped in half. But isn't that half branch still bigger than a smaller branch? Anyway, so it's going to be rounded, of course. The default equation was in years. I even wrote years for you. Khan Academy will do the same thing. This is in years, but I want to see what's happening every month. So again, I don't care about 15. Cross out 15. I don't care about the initial number of branches. I want to get a certain form. Can someone help me out? What is the form that I'm looking for? It's very similar to this last form, where I have a box on the inside. Can someone set that up for me? I see Justego's hand, Gio's half raised hand. Stego, go for it. Box, close parentheses to the power of t, exactly. I need to figure out what thing to multiply 3.2, or 3.2 to the power of what. That's my answer. Yeah, thank you, Stego. All right. Let me ask you this. How many months are there in a year? Quiet raised hand, James. Yay. 12 months equals 1 year. All right, we started with years and we need to go to months. Does that mean we are multiplying or does that mean we're dividing? And on top of that, what is my fraction right here in that yellow box going to be? Quiet raised hand. Eva? We are in fact dividing now. We have a year and we need to get to a month. Month is a smaller amount, so we need to go from big to small. I need to divide it down. Yes, so it was 12. I need to make it 1/12. Our answer here is 1/12. I need to somehow enter this into my calculator. Again, I can just do 3.2 to the power of, in parentheses, 1 divided by 12, and I get 1.10. 1.10. Done. Almost. All right. Go ahead and write your summaries after you finish copying down those notes. And I think the Khan assignment is already up.